Good afternoon, everybody. It's great to be here again at KotlinConf. A little more jet-lagged than San Francisco. I'm coming here from Vancouver, BC, Canada. So my name is Neil Power. I'm a senior software developer at Hootsuite. And I'm here to talk to you about Atlas and Hestia, dependency visualization and management with Kotlin.js. Before we begin, I wanted to first share this XKCD comic, which motivates me a lot in what I do. Maybe you've seen it before, or if it's your first time. At Hootsuite, we have 10% time, one day a sprint that we get to work on side projects, tooling, whatever we want. We also conduct hackathons twice a year. And I usually use this time to build tooling to save myself and my team time. And one thing that I also like is when I can share the projects that I'm working on with the wider world, the savings multiply. So if I can shave 5 minutes off something I do daily, I could spend 6 days doing that efficiency, and I'll make it back in 5 years. So an outline of what I'm going to talk to you about today. First, why am I here? A little bit of background into the projects. I'll talk a little bit about how we work at Hootsuite, give a brief history of the Android development at Hootsuite. Then I'll talk about the Atlas tool, the Hestia tool, some of my experience working with Kotlin.js, the tool's extensibility, and finally, some concluding remarks. So let's start with a little background of why I'm here. I was an Android developer at Hootsuite from 2015 to 2017. Since 2017, I've been working on the developer products team, building our Hootsuite developer platform. Unfortunately, that means my day-to-day is no longer Kotlin. It's mostly Scala and refactoring PHP. So it's really great to be back here among like-minded people. But my daily experience with Kotlin now is the tools that I build, Atlas, Hestia, that I'll be talking about today, as well as other tools like Hermes. So why am I here from Hootsuite? Well, Hootsuite has a culture of experimentation. We were an early adopter of Kotlin in production, and while we were growing our Kotlin skill sets, we developed some in-house tools written in Kotlin that I'm going to share with you today. As I mentioned in the last conference, last KotlinConf, Hootsuite has a culture of working out loud. And to work out loud, to me, is to work passionately, know that what you'll be doing is going to be valuable to someone, and then strive to share what you're working on with those around you. So let's start with a little background information about the projects. As I mentioned, last year I spoke at KotlinConf about our experience adopting Kotlin at Hootsuite, how we grew the culture there. In that talk, I briefly spoke about our Atlas and Peon tools that we wrote in-house and we use daily to improve our developer experience, especially on the Android team. And those tools at that time were written in Ruby and have since been rewritten in Kotlin.js. As I don't think Blizzard would want me using the Peon images that we've been using in Slack from Warcraft, we've renamed Peon to Hestia. Hestia is the goddess of architecture, making it a fitting name for the tool, as I hope you'll see. I don't know why I like to name all the tools after Greek mythological figures, Atlas, Hestia, Hermes, but I do feel bad for my future children. So before I talk about the tools, it is important to talk about how we work at Hootsuite, what problems we had, which led us to the creation of Atlas and Hestia. And that's hopefully something that you'll be able to use to see if these tools will be right for your work environment. At Hootsuite, we have a core mobile team focused on our core's app functionality, login, security, holding on to tokens, etc., and also splitting the app into project verticals, as we call them. And these verticals are worked on by teams around the company, which we call this process library-driven development. You see here we have the Hootsuite main app, and one of those verticals is Engage. I don't know if you've used Hootsuite, but it's a social relationship platform. And we show streams from Facebook, from Twitter, from LinkedIn on our web product and our mobile products, and people engage with those streams. We also have a plan and create where people send messages to social networks. And each of these teams have their own dedicated mobile developers. So in addition to the project verticals, we have other modules in our Android app and iOS apps, which are in-house libraries built into the final app. You can see here a sample graph generated by our Atlas tool for our Android libraries. And some of these libraries, like Logger or Publishing, are simple utilities just to facilitate code reuse across different verticals. The graphs that I'm showing you here are snapshots of our internal Android libraries at different points in time. Each node is a single repository which one or more teams contribute to. And then at the top is our main app where all the libraries get built into and shipped to our customers. You can see on the zoom in here we have versions on each of the libraries as well, and the version where each, so this is our publishing library, version 0.2.14. Publisher is depending on that version of that library. And all these graphs are generated by our Atlas tool. In addition to Android development, we also practice library-driven development on our iOS teams using Swift, as well as our backend services teams writing Scala and Go. I'm going to go over a very brief history of Android development at Hootsuite to show you why we need Atlas and Hestia. That is mainly due to the decomposition of our Android app into libraries. In late 2015, we started to consider the problem that we had one large Android code base, and then we envisioned having composable libraries, each in their own repository. At this point, we had one giant app. Through 2015 and into 2016, we started putting features into their own libraries, and in doing so, refactoring old code out of the main app. It was April of 2016 that we started Kotlin, and soon after that, we started writing all Kotlin libraries. Our main app was getting smaller. Now, in 2018, we have many libraries, most of which are entirely in Kotlin. Different teams own and maintain the libraries, as I've said, and these libraries are composed together to build the app that we ship to our customers. So this decomposition meant that we were putting new features into their own libraries, but we also, as I said, refactored a lot of legacy code, pulling it out of the library into reusable library components. So what was our motivation for doing this? One, it led to better architecture. At least that has been our experience. When you separate libraries out of a single monolithic code base, it forces you to consider the interfaces between the features and the main app. It's harder to sidestep and make shortcuts. It also, historically, allowed us to introduce Kotlin in a steady but controlled way. We were able to write new features in Kotlin, but also continue to refactor the old app into newer Kotlin libraries. So here's the dependency graph that I showed last year, this time at KotlinConf. Our core app still containing tens of thousands of lines of legacy Java code, and our progress toward refactoring and rewriting app features in Kotlin. This was the state last year with a number of libraries still in Java. As you can see, even in a year, we've added several new libraries, as well as new tools, and the progress that we've made in Kotlin development is striking. All but 5 of our libraries are now majority Kotlin. But you could see that the graph is increasing in complexity, so we needed tools to manage this complexity. So some of the benefits of the decomposition that we noticed, as I mentioned, it was easy to make new libraries Kotlin only. It's easy to delegate ownership to different teams. And there's much faster builds when we're using pre-compiled modules shared across the development teams. However, there's some drawbacks. There's an increased overhead for project configuration, which we've mitigated somewhat with library templates and scripts. But the main drawback is that you need to keep all your libraries versioned and in sync, much like external Gradle dependencies. So we have, as I mentioned, our engage feature vertical. That had a certain version which needed to be brought into the main app, much like RxJava, RxKotlin, Dagger. You have to keep them in sync across our entire ecosystem. So if library-driven development creates that development overhead, what can we do to ameliorate it? Who wants to manually bump versions of internal libraries? When a new version of Kotlin comes out, who wants to go through every repo they own, bump every version, bump the version of those versions, and so on, cascading up a graph? At Hootsuite, our solution has been Atlas and Hestia to mitigate this overhead. So now that we've seen how we develop Android at Hootsuite, let's look at the first tool, Atlas, which helps us visualize our dependency graphs. Atlas crawls one or more GitHub hosts, github.com for public repositories, or our private GitHub enterprise server, looking for organizations of repos or repos themselves. After it crawls through GitHub, it parses and reads dependency files. For Android, it reads your build.gradle files and other Gradle files. For Carthage on iOS, it reads iOS dependency files. And we've recently added SPT support, where it reads build.spt files. And from these parsing of the files, it builds the dependency graph, which can either be visualized. We use graphviz as an open source tool to visualize the PNGs that I've been showing you, or we can use it as a data structure. And like I said, all the graphs that I've shown so far have been generated through Atlas. As I also mentioned, it started as a Ruby application just to determine the project dependencies. And we've since rewritten it in Kotlin.js. We use it daily to create dependency graphs for iOS, Android, and Scala projects. So Atlas can visualize the graphs to help our developers understand the projects better. In addition to outputting the images, it outputs a state of the graph, which I'll talk about when I talk about the other tool, Hestia. So here's a simplified graph generated by Atlas for our Android projects. You could see, although it's a little small, this composer is our compose vertical. You can see our sending SDK, which is an SDK to send messages to the social networks. Hootsuite core, which is our core networking library. Unfortunately, at this point of the graph, we still depend on a fork of an old Volley library, which we've since removed. And this is all generated with graphviz. The PNG, of course, you can see immediately the hierarchy from the main app to the features, to the tools, to the core tools. But if you look up close on the graph, you'll see some features of Atlas. Visually, Atlas will show out-of-date dependencies with Amber. You'll see here that a social network picker UI, a library that we use to show Twitter and Facebook social network profiles to the user, is Amber. And it's because version 1.16 is what's actually being brought in to the main app. So it highlights that we really should be updating the dependency on the newest version of this social network picker. Also in red, you could see mismatched dependencies. For UI core, it's Amber because we're depending on an older version. But since this older version doesn't match every other version pulled in, we're coloring that line red. And these are where the real problems appear. And we've seen before the Atlas tool actual runtime crashes for our users because we had some transient dependency issue where we changed the API but failed to update it across our library. So what do we use Atlas for? Well, one thing that I find great is just simply onboarding new Android developers. I remember when I got to Hootsuite and they were talking about decomposing our app and all the feature verticals, it was hard for me to keep it straight in my head. But now that we've found, with new developers, with the Atlas tool, they're able to understand the development ecosystem faster because they can see each of the pieces that they work on represented in the graph and how they relate to each other. And if they're working on a feature team as opposed to the core team, they could see which shared libraries their feature vertical depends on so as not to cause problems for other teams. We also show Atlas graphs on status boards around the office. It's a reminder for teams to fix dependency issues if it gets too red or too amber. We also use Atlas to diagnose bugs in development. If there's a shared library that has different versions being imported into the final app, this can cause issues, which we're able to diagnose and fix. Finally, we use the output of Atlas to perform the graph building and sorting for our Hestia tool. Recall that Atlas can either output its graph as a PNG for graphviz, or it can output the graph data structure to the other tool. So that other tool is Hestia. As I said, it was previously called Peon and is called such in my talk summary. It's another, or was another, command line Ruby application that we rewrote with Kotlin.js. It takes as an input the graph data structure that Atlas outputs, as well as any dependency updates that you wish to apply. I'll show you how you choose which dependency updates you wish to apply shortly. Hestia then topologically sorts the graph using Atlas and creates ordered pull requests with given changes. So you can see here in a GIF before and after Hestia was run. Before, we have many mismatched or outdated dependencies, many Amber libraries. And after, we could see that the graph is nearly problem-free. That is, that the Amber outdated dependencies and red mismatched dependencies have been resolved. So the change you can see originated in this Hootsuite core version, where we bumped it to version 1.75 across the libraries. And then, for example, the Streams SDK, its version also got bumped because it takes in the new version of Hootsuite core, cascades that change up to the engagement library, which cascades that change up to HootDroid. Since the graph, however, is topologically sorted, we are making linear changes to the graph. We only need to make changes to each repo once. In order to explain how Hestia achieves that, I will quickly go over topological sorting, the algorithm that Hestia uses. So if we have a dependency graph such as this one, where each node is a repository that could be changed, here node 9 is depended on by node 11, which is in turn dependent upon by node 7. Node 9 is also dependent upon by node 8, which is dependent upon by node 7. So if we want to make changes to node 9, if we've noticed a bug in one of our libraries, we'll have to propagate those changes to nodes 8 and 11. And then the changes for 8 and 11 will themselves have to propagate further to 5, 7, and 3. So if you had to do this manually, it would be a bit of a headache. And to determine how to make changes once per repository in the right order, we topologically sort the graph. One such ordering here, to maintain the same dependency structure, sees it go 5, 7, 3, 11, 8, 2, 9, 10. The same graph just represented linearly. And in topological sorting, you can see that the dependency only goes in one direction. 5 depends on 11, but nothing to the right will ever depend on anything to the left. So if I go back to the change example that I had previously, where we want to make changes into node 9, it knows that the changes will have to propagate up to its parent from node 9 to node 8, to the parent 11, 3, 5, 7, and 5, the grandparents. So if we make changes in this order and merge the pull requests, with respect to the topological sorting, the new versions will be available when the parent needs them. So we use a private Maven server to hold all our artifacts. And then by the time 9 is merged in and built, 8 will then be able to start building, and then 11, 3, 7, 5. So here's the output of Hestia in Slack. It operates on the topologically sorted graph, and it messaged the ordered pull requests necessary to make the changes. So this example here was last year when we bumped Kotlin to 1.1. Rather than taking a day or a day and a half of time to make sure that we properly propagated it through all our libraries, with the push of a button, we were able to generate these 21 pull requests. So it messages us to take a look at the pull requests. So we could have, and in fact, it would have been easier to make the tool merge the changes automatically. However, our SOC 2 compliance people were not quite happy about that. In fact, they told us whoever even triggered the build wasn't allowed to approve the pull requests to maintain SOC 2 compliance. So instead, Hestia shows in Slack the pull requests, lets the developer examine them manually, merge them, make sure the tests pass, propagate the changes all the way up. So at the bottom, for a leaf on the vent bus tool, for example, you'll see the simple changes. This is the pull request that's generated by Hestia. Kotlin version is changed to 1.1, and the version of the library itself is changed to 1.03, both of which is done without human assistance. At the end, with all the libraries updated, this change to our Hootdroid, our main application, contains all the changes cascaded up through the graph as the libraries were bumped to Kotlin 1.1 and had their own version bumped. So that, having a major change like Kotlin, you can cascade through the entire graph in one go. However, not all changes need to be so extreme. And I'll show you. So this is an example of how we trigger Hestia with Jenkins, but it's a little unreadable, so I'll just go through it in a table. For SOC 2 compliance and to maintain best practice, the developer triggering a Hestia job must provide a commit message and a Jira ticket for the tool to work. Here we're telling that we're updating an Android support library. Hestia can be either run on a single repository if you want to make changes if there's been a bug fix, or it can be run on the entire org, the entire graph of our workspace. You can also use it to bump versions like Dagger or RxJava. The desired changes to the graph are passed as artifacts. Either internal or external libraries to be bumped are passed here. So you can see we want to bump the version of the Hootsuite query builder library, though this could just as easily be a Dagger 2. We also allow properties parsing. So if we want to change our min SDK version, another thing that used to be very tedious, we can just pass it through Hestia and have it propagate through the graph. If we're operating in a single repository mode, I've shown you that the version changes happened automatically, but all it does is normally bump the patch version. So if you've made API breaking changes and you want to specify a minor or a major version change, you can do that as well. And the beauty is, even if there are breaking changes, you can then, when the pull requests are generated, go in, make the fix necessary to update the newest API, merge, and so on. It still generates the skeleton of the pull request for you. And finally, Hestia messages the changes in Slack as I showed above, so the developer can pass the names of the people they want to look at the pull requests here. So now, after I've talked a little bit about the tools, I'd like to talk briefly about my experience with Kotlin.js coming from Ruby. So as I said, both Atlas and Hestia are written in Ruby, my kind of default scripting language for a long time. And rewriting in Kotlin.js was a very interesting experience. Both implementations, for example, use GitHub's official API clients, OctoKit. Kotlin.js uses the JavaScript version, and the Ruby implementation uses octokit.rb. Here is a way that I call my OctoKit client, and I'm looking to get all the repositories in an organization. Then I iterate over those repositories. Here, of course, with Ruby or any weakly typed language, I need to be fairly confident that my implementation and what I'm doing to this repo list and iterating over the repos is correct. And then when I call the contents here to get the contents of a file to parse, similarly, I might have to throw an error, I might have an OctoKit error, and I have to kind of trust, of course, that my implementation is correct. However, with Kotlin.js, I'm able to spec out the GitHub API provided by OctoKit. I could describe the data classes, so I have my repository information, for which I actually just need the name and HTML URL. I have my file information, which I need the name and the base64 encoded file contents. I have those same methods in an external class above, get for org and get content that I showed in Ruby, but rather than not knowing or not being confident that I'm having the right response deserialized, I know that it's going to be Kotlin's implementation of a JavaScript promise, wrapping a GitHub array response, wrapping a repository. And I'll immediately know that if it's not the right structure, because the Kotlin type system will step in and throw an error if it doesn't match this spec. And beautifully, of course, with the external class, I don't need to implement these functions. I only describe them based on the documentation from OctoKit. And even in the objects, like I said, I only use what is needed. If you look on the GitHub API, repo is huge, but it only deserializes the fields that I want. Similarly, I'm able to do the same with the graphviz library. Both our Ruby implementations and our Kotlin.js implementations use the open source tool graphviz that we pull in from NPM or pull in from a Ruby bundler. Having that type safety in Kotlin makes the code more reliable, more readable, and far easier to test. You can see here I've specified some default graphing options, and I have the similarly external class described that gives me a promise of a byte array. So instead of using bundler to bring in Ruby libraries like OctoKit and graphviz, which if you've ever used Ruby is a great strength of the language, we're able to use NPM to bring in similar libraries in JavaScript. But with Kotlin.js, it provides much needed type safety, null handling, all the features that you love about Kotlin in a scripting environment. And then after packaging Atlas as a common JS module, we can import it into Hestia and call it similarly as we do OctoKit. On Ruby, we bundle up Atlas and import it into Hestia as a Ruby bundle, and in Hestia at Kotlin.js, we import it as an NPM module. And for my experience from this project is that the next scripting project that I'll start, I'll definitely choose Kotlin.js over anything like Ruby. So the tools, Atlas and Hestia, are meant to be extensible. And when we open source them, anyone will be able to extend Atlas and Hestia for their own use cases. As I said, we use Atlas daily for iOS and Android dependency visualization. The iOS dependency graph is quite dense, and unfortunately, Hestia does not yet support updating and fixing some of these graph problems. This is our current dependency graph for Android, and it looks like we should be bumping that Hootsuite core library to make the changes up through the graph. We added SBT support for Atlas to help us visualize Scala dependencies at Hootsuite. This is a project that we undertook as a hackathon. Scala at Hootsuite is much flatter, i.e. we don't have as many nested levels of hierarchy, but it's a much larger graph. There are a few key Scala libraries depended upon by most of our Scala services at Hootsuite. We have a VIP Server library, and it powers many of our legacy services. When we implemented and ran Atlas on all our VIP services, many of them are not depending on the correct version of VIP Server. Because there are so many more Scala teams at Hootsuite than mobile teams, the problem of keeping our internal dependency graph up to date and communicating that with other teams is an even greater challenge than we face on Android or iOS. You can see the graph of a health checks library that we use in each of our services to provide status updates and monitoring. Our akka graph is even messier. Most all of our services depend on one version or another of an akka library. It's an actor model for Scala. Finally, here is all of Scala at Hootsuite. At the moment, it's an unreadable web, though we are working to fix it piece by piece. And if you had it in front of you, you could zoom in and see every version of every Scala library depending on every version of every other Scala library at Hootsuite. We've even been able to create a POC that Hestia can work with SBT, simply bumping a version of a version.scala file. And we'll continue to add proper support for Scala and Hestia because, as I said, since there are so many more Scala developers, the benefit will be much greater. So in order to facilitate adding support for other languages and build systems in Atlas, we've created an interface called a GitHub worker that we or third-party developers will be able to implement. The implementation of this interface knows how to crawl GitHub files for dependency information and to compile that information into a graph. At the moment, we have a Gradle worker that parses build Gradle files to generate a graph, an SBT worker that parses build.sbt files for the graph, similar for the iOS, and similar if we were to add NPM support to parse package.json files is the next goal that we want to be able to visualize our JavaScript dependencies at Hootsuite. So the worker also needs to know how to find the source code of the dependency. Otherwise, you're only going to get one tier, because it's easy to tell what version of a library depends on any external library. But if you can't look at that external library's code, it's difficult to get the dependency information for it. For our internal libraries at Hootsuite, it's quite easy, because all our code is in our private GitHub Enterprise server. So we know when we're parsing our build Gradle file, and we see query builder or com.hootsuite.android query builder, that it's going to be in our private GitHub repository. But if we're implementing to look beyond into public GitHub, you could use, for example, a whitelist that it knows where to go to find the code for each library. So after support is added for a language in Atlas, support can be added in Hestia. There's a similar interface in Hestia which, when implemented, knows how to make the alterations to dependency files based on the input I showed above. So it knows how to bump, for Android, it knows how to bump the min-SDK version, which is not present in Scala, and all the other language-specific features, or build system-specific features, rather. And the common aspects of Hestia are reused across both SBT and Gradle, syncing repositories, committing changes, creating pull requests, etc. At the moment, we've fully implemented Hestia for Gradle, for Android, and we're working on an MVP for Scala, for SBT for Scala. So finally, in conclusion, to revisit this slide, both Atlas and Hestia have saved countless developer hours. What was once a tedious process of updating Kotlin versions or libraries in our graph is now reduced to about an hour of work on Android. In the couple developer weeks that we used to go into each of the tools, we've saved hundreds of developer hours more than that. And it's our hope that by open sourcing these tools, we'll save others hundreds more. So as I mentioned, I've been working to open source the Kotlin.js versions for Atlas and Hestia, something that I was hoping to have done by the time of this conference. But due to my demands of my day-to-day job, my goal is now to finish it in the early November. If you're interested in yourself using Atlas or Hestia, please reach out to me by email or Twitter or anything. And both projects, when they're approved after the security review will appear on our public github.com/Hootsuite. So after being open sourced, our plan is to distribute both the tools as common JS modules distributed through NPM, such that even you wouldn't need Kotlin JS, you could just use JavaScript. So we're going to continue to work on improving Atlas for SBT, as well as Hestia for SBT as well. Finally, we're going to allow third parties to implement their own workers so they can use Atlas with their own technologies. And just as an aside, if you want to see another Hootsuite open source Kotlin project, a configurable GitHub Slack integration using Ktor, it's already open sourced at the Hootsuite/Hermes. I'd be happy to chat about that anytime as well. So I just want to, before I finish, give a few shout outs to the people who've really helped make this project work. Ben Hergert, the original author of Atlas for iOS. Simon C., who built Hestia with me the week between Christmas and New Year's, in a week of frustration of bumping min SDK versions and bumping libraries over and over again. Jim Rieken, Adam Arsenault, Diego Alvarez, Sherry Yuan for helping me add Scala support to Atlas. And Ben Hergert and Andy Fisher for helping me rewrite Atlas in Kotlin JS. Thank you.